Hey, hello, SolarLune here. I'm an independent game developer and the creator of Master Plan and Tetra3D. Tetra3D is a 3D renderer made in Golang with a Engine, which is a 2D game development framework, but I'm using it to make Tetra3D. I'm the creator of it. And so I'm using a 2D framework to make a 3D renderer, basically. And so this is a very PlayStation 1 styled 3D renderer where you have affine texture maps and texture mapping and stuff like that by default, low poly objects, very PS1 core. And so I just wanted to show this thing I've been working on, which is light volumes. So you can see this is a scene where I have controlled this little character. As I walk into this doorway, my character gets darker as he's in this space, and then when he walks out, he gets lighter. And then there's a bridge here. When he walks under it, he gets darker, and then when he walks out, he gets lighter. This is so cool. This is the dopest thing. This is so sick. This is so sick. I'm ecstatic about this because this is something that I feel like adds a lot in terms of the atmosphere, to a scene, and it's something that I feel like I never really thought I would be able to do because I was thinking, I'm making a PS1 style renderer, so I'm trying not to use shaders and stuff that much if I can help it. Trying not to do things the way modern engines do them when it comes to like shadows and things like that, where you're rendering things from the cameras, the light's perspective, and then you're projecting it over the scene. Rather than that, I'm trying to be like, okay, well, how would a PS1 do it? And I feel like light volumes are pretty much as close as you would be able to get on a PlayStation 1. Like the fidelity is surprisingly good enough for this resolution and for low poly. It feels like this actually is pretty convincing. So yeah, I thought it would be cool to kind of look at it and show what it does and how it works. It's pretty simple actually. It's not too complicated. If we look at Blender, this is the map that we're walking around in. This is the character here, and then this is the map. We have a big, I almost said sphere, a big cube surrounding our scene, which is our light volume. And so this is also really encouraging because the light volume is massive, and yet we're, running around really efficiently. You can see that the frame time for lighting is super duper low. 0.06, 0.04 milliseconds, which is good. That's really good. That's surprising. I thought that it would be slower. But anyway, this might, I might need to work on it still some more, or I might be missing something. But if those measurements are correct, that's fantastic. So basically, this box represents the light volume, and it's essentially a big grid of colors. So you split up the grid according to a cellular size, whatever the size is. So in my code, I have it set to basically 2 units between each cell. So this is a cell here roughly around this square. These 4 squares here is a cell. These 4 squares is a cell, and so forth and so on all the way through. And so these 4 is a cell. These 4 is a cell, like that. And horizontally, vertically, and depth wise. And so you get this grid. You then can color stuff in the grid, and objects that pass through those points in the grid get colored. They get lit, either additively or subtractively. And so you get this really cool effect where it's like, oh yeah, I'm walking under things, and so I'm getting darker as though it's shaded. Or I'm walking, another thing I could do is to make it so that certain materials or grounds are like emitting light. And so the light volume is emitting, basically those points in the light volume are brighter. And so, for example, if you walk over a green, like grass, then your character would turn green in the lower part, like not fully green, but part of his lower portion of his body would turn a little green. Like that's basically simulating what's now known as global illumination. But to see it done here like this, sorry, I forgot. Well, anyway, to see it done like this using vertex colors is just so unique and cool, and it doesn't look like anything else. It looks very unique, very retro, very much so like something that they could have done only or would have tried on the PlayStation. Like this would have been the only way they could have done like dynamic lighting, like yeah, where they have shadows and stuff. I don't know. It feels like that, like that's how they would have done it if they tried to do it. So anyway, this is super duper cool. And the code is super duper simple as well. So we were making a new light volume from the big cube in the scene. And then we basically just loop through each point, each cell, and basically determine, okay, well, what are we going to do? Are we going to darken it or are we going to lighten it, essentially? Or are we going to darken it or are we not going to darken it? And we do that by simply casting a ray. If we do a ray testing and cast a ray upwards and it hits the sky material, which in our scene is this, all of these squares here. We can actually select them like this. So if it hits a sky material, then that means obviously we have a clear shot to the sky, so it should be lit. Otherwise, we want it to be dark. And so that's basically it. That's the concept. Super duper simple. And if it's not lit, if it should be darker. Oh, if it's not lit, then we basically subtract 1. Basically like a negative energy of 1 on all colors. If we wanted to only do one color, for example, we could say, oh, only subtract blue. Ooh, that looks nasty. That's interesting. That's really interesting. So I'm coloring the shadows, and you can see my character just barely getting a little like greenish tint as he walks through here. You could do it the other way. Yeah, whoops. Where now the shadows are blue. So it's pretty interesting. It's pretty interesting, really dynamic, really easy to use. Something that's kind of interesting, I also have a function to blur the results. Without blurring, you get this. You can see the effect much more dramatically, I guess you could say, where like the points are is a little more obvious, just a little bit more obvious, not super, you know, to a great degree. But once you blur it, it really like looks pretty good. And something else I really like is by blurring, you also have some spillover, which simulates light pretty well. Like there's no light here. You can see it's a hard line here. So if I walk down here, it's dark. But if I blur the scene or blur the results of each light cell, now we have much more natural light that kind of flows. And so it kind of bleeds over a little bit into this part. So it's a little light down here. That's really cool. I think that's just really cool. That's really realistic. It's surprisingly realistic, where it's like, oh yeah, there's a little light here. There's a little light here, right? Because it's kind of on the edges of the transitions. It's really good, man. I don't know. I think this is really, really cool. I feel like it's maybe it's not perfect, but it does do a lot of what I want it to do. It's really good. And this is a little dark. The scene's a little dark. Trying to tweak it so it works exactly perfectly is a little interesting. It kind of feels like the last 25% of like 100% energy is kind of darker in a sense. Like if I go to negative 0.5, it's dramatically brighter. Like it's dramatic, you know, the shadows aren't nearly as dark. So it's like the last 25% is like really aggressive, which is interesting. It's an interesting property of subtractive lighting, and I feel like that's something that the PS1 probably, you know, kind of visualized more. Like when you think about, for example, transitions between levels or between scenes on the PS1, it feels like what a lot of the time the game would do is it would draw a black screen or something over the game scene, the game screen, and it would fade the screen in, but the screen was set to be subtractive coloring. So basically you would get this kind of really crunchy, like aggressive fade that nowadays we don't really use. We just use normal alpha fading, right? We just fade the texture, fade black normally, whatever. But the PS1 had these really kind of aggressive colors when it comes to just colors in general. And I feel like that you kind of see that here. You don't usually see that. Anyway, I'm just really cheesed about this. I think that this is such a cool effect. It looks really good. It feels really good. It's running well. Go's a great language. Love Go. Yeah, I'm pleased, man. I'm pleased. I'm super pleased. And this is the same renderer that I'm using to make this other this project, this game I've been working on that's like supposed to be super moddable and stuff. So you'd be able to use this in there. So people are gonna be able to make some cool stuff, man. I'm so like excited. It's such an exciting renderer. So exciting. So yeah, if you want to check out Tetra3D, please do feel free. It's on github.com/SolarLune/Tetra3D. I'll probably be pushing this out pretty soon because I feel like it's pretty good. It's not perfect, but it's, I think, more than good enough to use and to mess around with, play around with. This demo is, I think, a pretty good little demo that shows how it works. There's some things that I would really like to do. Something I wish is, I wish the underside of this bridge was dark like this wall. The reason why it's not is because the bridge is thin and the bottom side of the bridge doesn't touch the next point down in the light volume that's darker. So the bridge is casting shadow essentially, and so the point underneath the bridge is dark. But because these triangles, these vertices, the vertices of these triangles are closer to the upper side of the bridge, these points up here, you don't get the darkness. So I'm not sure quite how to fix this. I can't quite like you run with a bias or like add the position of the vertices transformed with their normals, because it's kind of complicated. I think, like, I tried basically adding the normal of the vertices to their position to basically determine in what cell of the light volume they're in, and it worked for this, but it didn't work for the player, because basically as he moved around, he was like exhibiting light from like over here. It's like he was shifted. So it's an interesting problem. I'm not quite sure how to fix it, but it's not a huge deal. It just would be nice to fix. But overall, this is, I think, really good for what it is. I think it's stupendous. Of course, you could just make your level with the grid in mind, with the light volume in mind, so the bridge is just thicker. But I would like to kind of try to figure out a way to, like, lean, kind of lean towards the right answer, where it's like, oh well, the bridge is thin, so it's on this point up here, but because the normal's facing down, instead it looks at this point down here, which would be correct. But anyway, that's technical stuff. Yeah, I guess I could talk a little bit about the technicality of how it's working. Overall, it's pretty simple. It's just basically a packed grid of light values, and the light values are just colors, which are just RGB and A flip 32s. Really, now that I think about it, if it's lights, they probably don't even need an alpha, right? Because there's no alpha. They're just red, green, and blue. So I probably could reduce the size of this by essentially 25% by just reducing, getting rid of the alpha. So that would probably be a good idea. But basically, that's it. We have a global, or kind of like a global to the light volume, energy, and color. Excuse me, which can be useful if you want to maybe like tint an entire volume. Yeah, it's pretty simple. It's all kind of calculated ahead of time, so resizing the light volume is done ahead of time if you want to do that. Placing colors is done ahead of time if you want to do that. And basically the lighting function is where things that are lit get lit. It's pretty exciting. I'm really happy with it. Yeah, overall, it's not too complicated, not too difficult. There's still things, again, that I would like to do. I would like to kind of work with normals more, but I'm just not sure exactly how to do that with the current design. I might have to think about this a little more. I feel like if I, well, yeah, I might have to think about this a little more. What else? Something I was thinking about is maybe making an ability to add layers. So you could have like a layer for your lights, a layer for your shadows, maybe a layer for, you know, global illumination or something like that. But I feel like that both, you know, balloons the memory and the CPU cost of the light volume and doesn't do much in terms of, you know, net wins, because you can just program what color, what final color you want. So you can just, you know, you can manage the layers yourself. Like you don't really need to make another data structure for that. So I think it's fine. Yeah, pretty simple, pretty straightforward. I'm just super pleased and happy and surprised that this worked. It's dope. It's great. It's fantastic. I'm happy with this. 254 milliseconds to light. Whoops, to light this entire thing to run through all the cells in this cube. Yeah, I'm pretty happy with this so far. So anyway, yeah, please check out Tetra3D, github.com/SolarLune/Tetra3D if you'd like to check it out. And yeah, thanks for watching. This has been a cool little update video. I'm gonna release a new update for Master Plan. I know I was saying that. I am going to do that maybe to either tonight or tomorrow. So please look forward to that. All right, I'll catch you guys on the flip side next time. If you want to check out my streams, please do. Twitch.tv/SolarLune. Twitch. It's on on Monday, Wednesday, and Friday, usually. Sometimes maybe, sometimes usually. Anyway, thank you very much for watching. I'll catch you guys on the flip side. See ya.